Welcome back, ladies and gentlemen. Now, how do we find the radius of this radical geometry problem? So if I transfer that problem to whiteboard, you've been given a rectangle. You've been given a rectangle A, B, C, D, and an inscribed semicircle H, E, F, G. And you've been told to determine the radius of that inscribed semicircle. Now, this is quite simple. We have this small length HB is 1 and this small length BE is 5. So, if you divide it in this manner, remember the radius is any line from the center to the circumference. So any line from the center of the semicircle to the circumference is the radius. So if from H to B is 1, from O, so you can see there from O to E is the radius R from the center to the circumference. But from H to B is 1, meaning for you to get from O to this point, it is going to be R minus 1. Then again, the length OH is the radius from the center to the circumference is the radius. Then the length BE is the same as the length H to that given point. So it means if you let this point maybe to be X, then we have triangle OXH. So that triangle OXH is a right angle triangle. So if you use Pythagoras theorem, the two shorter sides, if you let, that is side A, side B, and side C, then we'll have C squared is equals to A squared plus B squared. Now C we have is R, so we are going to have R squared to be equals to A, we have is R minus 1, that is R minus 1 squared, plus B, we have to be 5, so 5 squared. So what do we get? We have here R squared. Remember, if you have the quadratic identity A minus B squared, that is A squared minus 2AB plus B squared. So if you expand R minus 1 squared, that is going to be R squared minus 2R plus 1. Then it is plus 5 squared is 25. Now R squared will cancel with R squared. Then we remain with 0 to be equals to minus 2R plus 1 plus 25 is plus 26. Negative 2R coming this side, or you simply add 2R on either side of the equation, then you end up with 0 plus 2R is 2R. This cancels with that is equals to 26. So for you to get R, you simply divide both sides of the equation by 2. Then you end up with R to be equals to 13. Ladies and gentlemen, that is the simplest means to find the radius of that inscribed semicircle. Thank you for watching and see you again in our next presentation.